12.2, converting between polar and rectangular coordinates and graphing polar equations. Well, we've already converted coordinates when they matched up with values that we could either use special right triangles or numbers on the unit circle. What we're going to look at today is how we can do that no matter what the angles are and what the coordinates are. So, if we know the rectangular coordinate, the x and the y, and we want to convert, well, no, let's start with r and theta. I'm going to use the one on the left. So if we know the radius, we know this value, and we know this angle, well, if we make a right triangle out of that, we can say to find x, the horizontal part here, the horizontal length, we're looking for that one, we know this one, so we could say cosine of theta equals x over r. Then if you multiply both sides by r, you get x is equal to whatever r times the cosine of theta is. We've done that before. Likewise, if we're looking for the vertical part, the opposite of that angle, and we know the hypotenuse, sine of theta equals y over r, and if you multiply both sides by r, we can get the vertical component, or the y value. If we're going the other way around, if we know the x and y, and we want to get r, well, to get r, we would just do Pythagorean theorem. X squared plus y squared equals r squared, or when you solve for r, we want the positive square root. And if you want theta, well, theta, this angle, if we know that leg and that leg, opposite over adjacent, tangent of theta will give us x over y over x. And so to get rid of tangent, if we do the inverse tangent of both sides, then that would give us just theta. So to get the angle, we're going to do inverse tangent. But there's one little catch here. Sometimes theta is going to give you, well, inverse tangent is going to give you like a negative angle. A negative angle would have been here. When we really want the positive angle, well, the same coordinates for that, when x and y would have the exact same signs, or the exact opposite sign, x and y, tangent would have to be the same value. Tangent's the same value in the first and third quadrant, or the second and fourth. So if the angle's negative, we have to sometimes add 180 to that to get to this angle over here. If we take this negative angle plus 180, that would get us to right there. And likewise, if we get a answer that's in the first, but if you look at the original picture, and you're going to have the ordered pair, so you know which quadrant you need to draw it in to match it. So if it's in the third quadrant and tangent gives you this value, add 180 to it to get to the third quadrant. So pay attention whether you need to go to a different quadrant or not for tangent, because that's the one catch we have on that. The other catch you've got to watch out for on this assignment is, are we in degrees or radians? And they're going to either give you units in the problem or tell you which one. Like these, if we're converting, if we know the theta, we already know the angle, they'll tell us whether it's degrees or radians, and that one won't matter as much. But if make sure you're in the right units if you're using a calculator. And if we're trying to calculate what theta is, we're going to need either that answer to be in degrees or in radians, and they would have to tell us one or the other. And so you got to pay attention to which units you are and which units you're looking for. So let's look at number one. Number one says we want to find in degrees. Okay, so let's look at what we have here. Rectangular coordinates are given. Find the polar coordinates in degrees. If the value can be calculated using exact values would have no rounding. That's what we did last time with the square root of 3 and square root of 2 values. We can use that. We're looking for polar coordinates, so it would be in terms of pi with exact and things like that. If it can be, we're going to do that. If not, we're going to round it to 3 decimal places. So they gave us the x and the y. So let's plot that ordered pair. So if we go to 2.8 on the x, that's positive. We went to the right. And negative, so we're down here in the fourth quadrant. So we want to get an answer that's in the fourth quadrant. Well, this is 2.8. This is 7.2. It's a negative 7.2, but the negative really only affects the direction. We don't need that negative value. So let's talk about finding the radius to find r. Well, r is the hypotenuse of a right triangle. So the square root of 2.8 squared plus, and it doesn't matter whether you use positive 7.2 or negative 7.2, because when we square it, it's going to turn out positive. We're going to tap that on the calculator and get our answer. So to calculate this, we bring up our calculator, and we need to be in degrees, but it won't matter for r. It only matters for theta, but let's go ahead and put it in there. Well, on yours, you should be able to just click on this and change it, but for some reason on mine, it won't let me do that. So I have to go to Document and Document Settings and tell it to go to degrees from here. My touch screen won't, for some reason, will not let me touch that part. So it won't, like I said, it won't matter for the r, so that won't be a big deal if we didn't get that done. But we were doing 2.8 squared. So 2.8 squared plus, and if you're going to put the negative, always put it inside the parentheses, negative, and like I said, for squaring it, you don't have to put it, because a negative times a negative, we know it's going to be positive. And the negative only gave us direction, which we didn't really need for the radius. So that to 3 decimal places would be 7.725. So 7.7, so this was r, and r equals 7.725. Now to get theta, if we look at this angle, the theta of this 7.2 and 2.8, tangent of theta would be equal to negative 7.2 over 2.8 if we worry about direction. If I worry about just this angle, I can take off the negative and just do tangent of 7.2, and to solve for tangent, I have to do inverse tangent. Whoops, I didn't mean to move the screen. So I would have to calculate inverse tangent to get rid of tangent. So inverse tangent of all this. So if I do inverse tangent, trig, inverse tangent of 7.2 divided by 2.8, 2.8, you know, so I left off the negative. That tells me it's a 69 degree angle roughly, that's in the 4th quadrant. Well, to get 180 degrees, I would have to take this negative angle and add 180 to it. So if I had left the negative on, I'm going to show you, that's what I probably would rather do. If I went ahead and put this negative here, it gives you the same value, but it actually puts it in the 4th quadrant. So that way it kind of helps you know, if you know what quadrant and where you're going, it kind of helps out. So we have a negative 68 degree angle. If I add 180 to that, correction, I started to say 180, I had to fix myself. I have that negative 68 degree angle, but I want it in the 4th quadrant, not in the 3rd quadrant, or not in the 2nd quadrant. I said 180, but I wanted to keep this angle. So I cleared off some stuff here, so let me fix this. We were in this quadrant here, and this negative angle is the negative 68 point whatever degree angle. So that's correct, but I need to go around 360. So I'm going to add 360 to that, not 180. So plus 360, and you get 291.252. So theta is equal to 291, or approximately, it's 291.252 degrees. And our radius, we said was 13.410. If I remember correctly, is that what I had? I've already arrowed off so many times. Gonna keep arrowing up till I see. 2.8 squared plus 7.2 squared is 7.725. I had something wrong on my written down piece of paper, so I had to fix it. So it's 7.725. I was like, why am I getting a 13? And shouldn't be a 13 there. I wrote something down wrong. Comma, the angle was 291.252 degrees. So there, our radius was 7.725. Our theta was 291.251 to be a positive angle in the 4th quadrant. Okay, let's talk about number 2. Number 2 says to, look at this one, we want, this is in degrees. So while I'm thinking about it, I don't know if I need my calculator or not, I'm going to go ahead and switch it to degrees. So document, for me, document settings, you should be able to just touch it on your, and no, I'm in degrees already. Never mind. Okay, I went there for nothing. Just pay attention. Okay. Cancel. Okay, couldn't get it to go away. Sorry. So, we're already in degrees, so let's look at this one. To plot this polar coordinate, can't draw a negative radius yet, so let's go to 142 degrees. Well, 142 degrees is more than 90 and less than 180, so it would have been in the 2nd quadrant. But, since we had a negative radius, we have to go all the way across. So this is in the 4th quadrant, is where we're looking at, and this is 8. And this was 142 degrees here. So that is 180 minus 42. This would have been 37. So this is a negative 37 if we went this way. So, or just look top at the angle, 37 degrees. So, how about 38? I can't add, can I? That's a 38 degrees. Sorry, not 37. I'm making a lot of little mistakes today. Sorry. So, to find the rectangular coordinates, we have to realize that we're looking for the adjacent, and we know the hypotenuse. So x is what we wrote at the top is r times the cosine of theta. So that's going to be 8 times the cosine of 38. And if we use our calculator, 8 times the cosine, helps if I get to where back to, let's get down here where I need to be, 8 times the cosine of 38, and you get 6.304 for the 3 decimal places. So that is 6.304 for the x value. To get the y value, we're going to do the same thing, but it's r times the sine of theta. To get y, we have to do r times, or the hypotenuse over the opposite, and then we're going to multiply by 8. So this is 8 times the sine of theta. 8 times the sine of 38. So, 8 times the sine of 38. 8 trig sine of 38 is 4.9. 4.925 to be 3 decimal places. So y is 4.925. But here's the catch. Look at the direction. This y went down, so this is a negative value. The x went to the right, so it's positive. So the ordered pair on this one, and right over here we have a little more room, is 6.304. And then the y is negative 4.925, and that's the answer to number 2. Because we're in the 4th quadrant. So let's move on to number 3. For number 3, so we're given a polar coordinate. So let's draw a polar coordinate here. And I need to go a negative 5 pi over 4. So here's 4 pi over 4. So 5 pi over 4 would be here in the 2nd quadrant. And the radius is 6. And that means this is 4 pi over 4, so we went. So this is just a pi over 4 right here. So let's see if I can make that pi over 4. And pi over 4 is 45 degrees. So we're talking 45 degrees in the 2nd quadrant, which means it's an isosceles right triangle, so we can be exact. In an isosceles right triangle, the hypotenuse is square root of 2 times the leg. So to get the leg, we have to divide by the square root of 2. And to do that, you would rationalize and make it 6 square root of 2 over 2. And 6 over 2 is 3 square root of 2. So each leg is 3 square root of 2. This one and this one. And we went left, so we got to pay attention to direction. So this one's negative. We went up, so the second y value is positive. So x is negative 3 square root of 2. Y is positive 3 square root of 2. And those are the exact values on that one. Well, number 4. Number 4, we are in, and when you're dealing with x and y for like number 3, we didn't have to worry about radians or degrees. We were given the answer in radians. We just had to think in terms of radians. This one says we want the answer in radians. The rectangular points are given, and we want to find the polar coordinates. So let's look at, well, I'm noticing 7, not even worried about this, the positive or negative. I just took 7 square root of 2, and I want to end up at 7 square root of 6. Well, that's times the square root of 3. If you're multiplying one of the sides by the square root of 3, we're in a 30, 60, 90 right triangle. So let's draw where this is. And I know it's going to be exact now. So we went right 7 square root of 2 and down 7 square root of 2. No, so we went right 7 square root of 6 and we went down 7 square root of 2. And this value, her vertical value is smaller than the horizontal one. The horizontal was square root of 3 times, so that's across from the 60. So this is the 30. And across from the 90 is always double what the short one is. Well, the short one's across from the 30, so we got to double that value, but don't worry about the negative. Negative was direction. This is going to be 14 square root of 2. So 14 square root of 2 is our hypotenuse, so that's our radius. So r equals 14 square root of 2. And then theta, we said, was 30 degrees less than 360. So theta in degrees would be 330. but we're talking radians on this one, so 30 degrees is pi over 6. So all the way around the circle was 2 pi, which is 12 pi over 6. And if we back that up, 12 pi over 6 minus pi over 6. 12 pi over 6, take off a pi over 6. Theta is 11 pi over 6 in radians. So our radius was 14 square root of 2, and our theta was 11 pi over 6. There's our ordered pair. Now, remember, we also could have had a negative radius. If we had a negative radius, it would have been in the second quadrant, and that would have been pi over 6 less than halfway around the circle, so pi over 6 less than pi. And pi, take away pi over 6, is 6 pi over 6 minus 1 pi over 6 would have been 5 pi over 6. So either one of those answers would have been correct. Okay. So moving on to number 5, this one says we're in radians. And so just while I'm thinking about it, let's switch the calculator to radians. So I have to go to Document and Document Settings. You can just click on the little radian icon up at the little logo up at the top. So just in case I do need the calculator, I've already got the right mode. So the rectangular coordinates of a point are given. So in a rectangular coordinate, we're going to go -4, which means left 4, and up 3.2. So in a right triangle, this was 4 to the left, this was up 3.2, the negative only determines direction, and we want to find the polar coordinates. Well, those are not, that's not we've got decimals anyway, so it's not a square root of 2 relationship or square root of 3 relationship. So this is a calculator question. So to find this theta, we would have to do inverse tangent of the opposite over the adjacent, and I'm going to leave off the 4. I already know what the angle is, so I already know which quadrant I'm in. So 3.2 over 4, and then we'll talk about it. So let's see. I need inverse tangent. Oh no, I hate it when my board starts doing that. So let me backspace that out of there. Inverse tangent of 3.2 divided by 4. 3.2 divided by 4, and that tells me that's the angle in the second, that's this angle right here. So that theta is 0.675. I'm going to write it as 0.675, but that's this right here. So I would have to subtract that from pi if I want to find that this is pi, and I want to go back that amount. So to get that, I have to take pi minus that 0.675. So now remember, I don't want to use the rounded answer to calculate with. So I'm going to take pi, come on, pi, my computer, it's being crazy right now, so let's see if I can use the cursor. Pi minus the previous answer we just got. I did not type the right thing because it cannot use the arrows right now. Pi minus, I'm going to arrow up once and press enter, and I got it that time. So to 3 decimal places, that'd be 2.467. So 2.467 is, we found the angle. Theta is 2.467. Now, to get R, I usually like to do R first. I should have done R for R. Well, that one's easier. That's just finding the third side of a right triangle, finding the hypotenuse. So square root of 1 leg squared. Oh, I should have put the 4 first. And like I said, it doesn't matter if you do -4 or +4 because you're going to square it. So square root of 3.2 squared plus 4 squared, and you get 5.12. Let me see. I think that's rounded it. 5.122. So RE is approximately 5.122. So in R comma theta form, you would say 5.122 comma 2.467. Okay, for number 6, the polar coordinates are given. find the rectangular coordinates. If the values cannot be calculated using exact values, and I'm looking at, this is a radian, it's in terms of pi. So that's a radian, but it's definitely not on the unit circle, so it's not a special case. So I need the calculator in radians, which is good. So we just did that, we're already in radians, so yeah. So to find the rectangular coordinate, let's plot where this coordinate is. So we're going to need negative 2 pi over 7. Well, this would be negative 7 pi over 7, so it's a lot less than that. Now, this would be this would be pi over 14. So 2 pi over 7 is actually going to be in the, come on. I'm trying to get, it's in the first quadrant. So this angle is 2 pi over 7. And this was 3. So to find x and y, we're going to have to use the functions that are at the top up here, where we know the hypotenuse. So to find x, that's at the adjacent leg that I'm looking for, and we know the hypotenuse, so it'd be cosine. And we said the hypotenuse 3 times cosine of 2 pi over 7 will give us our angle. So if we say that, we get, oh, I don't need that anymore, so 3 times, no, I didn't get the 3, sorry. 3 times, I have to put the times, but cosine of 2 pi over 7. 2, oh, I don't need control. 2 pi, here's the pi button. 2 pi divided by 7. And that is 1.870. So x is approximately 1.87. 1.87. You don't have to put the third 0 since it's going to stay a 0, and you don't have to put a 0. You can. It's not wrong to put it, but it's not necessary. Y is the opposite one, so that's sine. So 3 times the sine of that angle. Now, this did go down. So if we go down, that's an ugly looking 2 pi. I could put in the negative. Let's put in the negative because that's going to take care of making sure that we're in the fourth quadrant for that value. So 3 times the sine of negative 2 pi divided by 7. And that gets us negative 2.345. Negative 2.345. Hey, that's all consecutive numbers and consecutive in a row. Whoa, sorry. 2, 3, 4, 5. Anyway, so if I know the y is the x is positive and the y is negative, we don't have to add or subtract anything. We're in the right quadrant already, so we now know the ordered pair is 1.870, comma, negative 2.345. Okay. Now, let's talk about the backside. We are going to be graphing polar coordinates, or polar equations, sorry. To graph polar equations, we need to make sure we're graphing these in terms of radians. So our units are always going to be radians. So step 1, make sure you put your calculator in radians. Step 2, to enter a polar equation, once you're on a graph page, you go to Menu, Graph Entry, then Polar. So let's talk about that. So start on a graph page. So I'm going to bring up a graph, and I'm in radians, so I'm good. And if I go Menu, Graph Entry, number 5 is polar, we are ready to go. And all we have to do is type in the polar equation. So we're going to look at an example in a minute. Now, with polar equations, we're in terms of theta. So to get the theta button, it's same button where the pi is. You press pi and arrow all the way over, and you can see theta. And if you ever have to graph more than one, you're going to see, you can use tab to bring up the box to type in more than one equation. So there are some special names for some of these. When we graph polar equations, you'll see shapes that make circles. You'll see shapes that are called a cardioid, and shapes that are called I'm not even sure how to pronounce these terms, limicon, and an inner loop limicon. Now, the cardioid and the limicon look the same. The only thing I noticed on this one, the coefficients had to have been the same. This one, the coefficients were different. But we're not going to make you worry about any of that. I just wanted to introduce some names to you. And on the next row, you'll see some where they have a lemniscate. And you have some that have a curve, a rose curve, and another rose curve, and then Archimedes spiral. And if you're ever having to graph a r squared, I don't remember, it might have been this function that had an r squared. That's the one where you have to, when you solve for r, you're going to have a positive and negative, and the only way to type a positive and negative is to write it as two separate equations. So you'd put one on one line and one on the other, and that's what I've kind of done down here for you. So let's actually graph that one so we can see what it looks like, or how to type one of these in. So it was originally r squared equals 3 sine of theta. And so if we take the square root, we take the square root of both sides, 3 sine of theta. You have to remember to bring in a positive and negative square root. And do that on the calculator. So we'll do the positive. So positive square root of 3 sine. And then I have to hit theta, so I press the pi button and go all the way over to theta. And only need one of them, though. And press enter. And there's that function. I don't worry about the step or anything like that. And to get the other one, I hit tab. And I want the negative square root of 3 sine of, I don't know why it's doing that today, theta. And you press enter, and that gives you that one. Hopefully, I don't know if I typed something wrong, why it looks so much more larger than the other. If you wanted to do a new one, let's start with a new document, just to clear everything out of memory. No, I don't want to save it. I'm going to start with a new graph. If I wanted to do 1 plus 2, oh, I wanted to do polar, sorry. So menu, graph entry. We want to type in, by the way, if you ever need to type any kind of equation, you can always go to relation. But I'm going to go to polar. And I want to do 3 plus 2, we'll say sine of theta. So if it lets me do the theta without going crazy, and for some reason today it is being very temperamental on my board. It didn't get it, darn it. Let's try one more time. Theta. Got it that time. And enter. And that one was the numbers are different. If the numbers were different, it's one of these two shapes, and I think this was the one that had the different value. The coefficients were, the 2 and the 3 were different. If they'd been the same number, let's go look and see. If I hit tab and change arrow up to, I want to change this to a 2. Oops. No, that's not what I wanted to change. I wanted 2 sine. Okay, I wanted to change this to a 2 so that they're both the same. Now you get that shape, which is the cardioid. Or cardioid. Cardioid, I guess is how to pronounce it. So, part of your assignment is, if we had more time and spend more time on these, we would actually talk about graphing them by hand. But in order to save time, we wanted to show you how you can graph them on the calculator, and introduce you to some of the names. And let's see, that's all you need to know. You should be able to do everything on this assignment. Good luck to you.